The information presented in this training series is intended for true automotive professionals who are familiar with the concepts and tools commonly used to achieve perfect wheel balance. Wheel Balance 101: Why Wheel Balance is Important. Brought to you by
Perfect Equipment, balancing the future.
Nearly every day of the week, more than 175 million Americans take to the streets to begin a daily commute. Destinations like work and school are typical, and the average daily commute is nearly 26 minutes. These people drive miles and miles, all the while unaware of the parts and pieces that make up their vehicle and the important roles they play in their daily comfort and safety. Of all the parts that make up a vehicle, none are more important than the wheel assemblies. Each wheel and tire combination on a vehicle is vital when it comes to safety and comfort. A vehicle's wheels provide a strong and stable base for the tires to adhere to. The tires provide the traction control and cushioning necessary to keep the vehicle comfortably on the road. At high rates of speed, smooth rolling wheel assemblies can be the difference between having a comfortable, vibration-free driving experience or a shaky and dangerous one. It is important to remember that more than 175 million Americans commute every day, and precisely balanced wheel assemblies are important for safety and comfort. Wheel assemblies consist of a wheel and a tire. When combined together, they are designed to rotate around their center axis, which is attached to the vehicle's axle with lug nuts. When a wheel assembly rotates, especially at high speeds, it exerts a centrifugal force on the axle that depends on the location of the exact center of the wheel assembly. In a perfect world, the exact center of a wheel assembly would be, in fact, placed in the exact center of the axle. This would mean the assembly could spin perfectly at any speed with even weight distribution on all sides. From the front or from the side, you can see that the wheel is spinning in perfect proportion. However, wheels and tires are not manufactured in a perfect world, and even though they are both built to extremely tight tolerances, weight imbalances are unavoidable. Nearly every wheel has some type of imbalance or heavy spot noted in blue on the illustration, and most every tire has an imbalance noted in green on the illustration. These weight imbalances are typically very minimal in size. When you consider that a typical passenger car tire mounted on an alloy wheel weighs about 40 pounds, it's amazing that the total amount of imbalance is typically no more than 2 ounces, or about 1/3 of 1%. However, any imbalance is a hazard. Due to the weight imbalance, the exact center of the tire is compromised and the assembly rotates unevenly, often causing wheels to hop and wobble. In fact, a small imbalance of just 1/2 ounce at a speed of 65 miles per hour creates an outward centrifugal force equal to that of a sledgehammer. To offset this imbalance, a weight of some type must be applied opposite the imbalance area to equal out the weight distribution. This is shown in red on our example. With the proper amount of weight applied to the light side, or the opposite side of the imbalance, the wheel can now rotate with perfect balance. When discussing wheel imbalance, it is important to remember that wheels and tires are manufactured with unavoidable imbalances. The average amount of imbalance in an assembly is 2 ounces, or roughly 1/3 of 1% of the total assembly weight. A 1/2 ounce imbalance at 65 miles per hour has the same centrifugal force equal to that of a sledgehammer. And when an unbalanced wheel assembly rotates, it hops and wobbles. So how does wheel imbalance affect the comfort and safety of a vehicle? Imbalanced wheel assemblies increase vibration, especially at highway speeds. Increased vibration can decrease steering sensitivity, making it harder to handle a vehicle and increasing the possibilities of the vehicle swaying and drifting while on the road. This can be a danger to the driver and other vehicles. The increased vibration also causes suspension system components and tires to wear unevenly, which drastically increases braking distance. This could become a serious issue if the imbalance is allowed to remain for a lengthy period of time. Wheel imbalance can also have financial impacts, as increased vibration decreases fuel mileage and tire tread life. It is important to remember that wheel imbalance decreases steering sensitivity, increases vehicle sway and drifting, increases braking distance, decreases the life of suspension systems and tires, decreases fuel mileage, and decreases comfort. As with most drivers, the destination is the ultimate goal, but it is also important to ensure that drivers are safe and comfortable when in their vehicle. Routine wheel balance checks are important in order to ensure every vehicle is driving safely and comfortably at all times. This concludes Wheel Balance 101, why wheel balance is important. In our next training module, we will learn more about the different types of wheel imbalance and look at what causes wheel imbalance. This training series has been brought to you by
Perfect equipment. Balancing the future.